In this video, I want to show you how you could check if your calculated pH from your H plus concentration is reasonable. Not exactly correct, but is reasonable. And also, in the opposite direction, if your H plus concentration calculated from your pH seems reasonable. Let me start off by showing you some real simple H plus concentrations, like 1 times 10 to the minus 3 and 1 times 10 to the minus 4th. And the pH for those two are simply 3 and 4. Because remember, the pH is a logarithmic value, in this case a negative logarithmic value, of the base 10. So if you have 1 times 10 to the minus 3, the pH is simply that exponent, because logarithms are exponents to produce a certain number. In the example of 1 times 10 to the minus 4th, the pH is simply that exponent, 4 multiplied, in this case negative 4 multiplied by negative 1, which gives you 4. Well, what if you have an H plus value that is in between 1 times 10 to the minus 3 and 1 times 10 to the minus 4th? Well, your pH value is going to be somewhere between 3 and 4. And having a number line may help you see that a little bit better. So here's a number line. Below the number line, we'll say we have a H plus scale, 10 to the minus 4th at the low end, and 10 to the negative 3 at the high end. And then the corresponding pHs, the pH scale will have above that. pHs are going to be 4, as we said, and then 3. Okay. So this H plus value is greater than 10 to the minus 4th, but less than 10 to the minus 3. So it's, somewhere in between. So it seems to be, let's say, closer to 10 to the minus 4th. So I'm just going to put a mark there. Now, so logarithms are not on a linear scale. Just want to point that out. So this tick mark here is really trying to show us where the H plus concentration is. But anyway, you can anticipate now, this is the whole point, you can anticipate that the corresponding pH value for 3.5 times 10 to the minus 4th is going to be between 3 and 4. Why is that? Because this concentration is, we'll say, flanked or bracketed by 10 to the minus 3 at the high end and 10 to the minus 4th at the low end. So you would expect when you enter this in your calculator to get a pH of between 3 and 4. And so let's do that. Just drag this down. And it is 3.45 or 3.46. So let's say we have an example where the H plus concentration is 7.5 times 10 to the minus 9th. All right, well, let's bracket this H plus concentration with real simple exponential values. At the low end, we have 1 times 10 to the minus 9th. I'll just write 10 to the minus 9th here. And at the high end, we have 10 to the minus 8th. So now we can anticipate that our pH value for this H plus value is going to be between 9 and 8. So calculate that. It's 8.12 or 8.125. So what about 3.55 times 10 to the minus 5th? Well, at the low end, there is 1 times 10 to the minus 5th. At the high end, there's 10 to the minus 4th. So the pH value is going to be between 5 and 4. And so let's see what it actually is. .48. So now let's start with the pH value and estimate what our H plus value should be. So regarding pH high and low, that would bracket 6.34, think of the whole number pH values that would bracket 6.34. And we would have 7 at one end and then 6 at the other end. So that would be 10 to the minus 7th and 10 to the minus 6th, because 6.34 is right about there, let's say. So the corresponding H plus value we would anticipate to be between 1 times 10 to the minus 7th and 1 times 10 to the minus 6th. So we're looking at an order of magnitude of 10 to the minus 7th, something times 10 to the minus 7th. So let's see what that is. 4.57 times 10 to the minus 7th. So now we have a pH of 8.8, 9. Remember what whole number pH values would bracket this value, 8.88. So we have 9 at one end and then 8 at the other end. So we would anticipate that our H plus value would be between 10 to the minus 9th and 10 to the minus 8th. So we're looking at a value here expecting it to be something times 10 to the minus 9th. So the 8.8. So now let's figure out what that actual value is. So 1.32 times 10 to the minus 9th. And that's pretty close to 10 to the minus 9th, sort of like right around here, what that corresponding H plus value would be. So this approach to approximating H plus and pH also works for approximating pH and OH concentrations, because it's the same math. It's the negative logarithm of a concentration.